Hello, students, and how are you today? We're going to start talking about square roots today. We've had some exposure to squares when we talked about exponents, but today we're specifically talking about how we get to a square, which is the square root. We will start by thoughtfully answering a do now question about social digital behavior, or today is a day we talk a little bit about bullying. Not a pleasant subject, but it's important to recognize it and talk about it. Our objective will be to begin our investigation of square roots, and we'll look at the radicand sign. Our essential questions ask, what is a square root? What are the first 10 perfect squares? And how do I factor out perfect squares? We're going to watch today's video introducing square roots, which you're doing now, and will complete 2 pages. Review all of the work that I do on the whiteboard today and the examples. Those are really important. Maybe you should get a notebook out and copy some of those down. Remember, you're showing all your work, not just the answers. So for our exit ticket, we will complete this question or answer 2 questions. What are the steps to simplifying a square root? And why do positive numbers have 2 square roots? If you haven't finished the lesson, try to get the lesson done for homework. We don't want you to get behind. You're working hard. Remember, you want to put your camera on, especially at the beginning of the period when we have our discussion. Your name may be called at any time during the period, so remember that you're responding to get your attendance credit. And tomorrow is our first Wednesday of full day learning. So make sure you dial into all of your lessons. I've already set up my calendar appointments, so you should be all ready to go. So here's our do now topic today. Our topic is bullying. Is it okay to repeat or repost something that you are not sure is true? So I know we always learn not to gossip, but what about repeating online or reposting online? Does it matter that it's just digital? I want you to think about that question, and I want you to write a sentence or 2 right there. So we'll get back to our exit ticket in a few minutes. But let's look at square roots. So, a couple of things to know about square roots. First of all, let's go to our notes. Here's what a square root looks like, okay? And I'll highlight that. We have here the square root of 36. What this asks, what this means when we see that radical symbol, the radical symbol is the symbol that I just drew there, that's the radical. Okay, what it asks is, what is a number that when multiplied by itself equals 36? So a square root is asking what times what, and it has to be the same number in both places, equals 36. So not all numbers are perfect squares and have a perfect way to get there by multiplying any number 2 times. Well, we can look at this by trying different numbers we know. We can try 4 times 4, but that only equals 16. So that is not correct. We can try 5 by 5, but that only equals 25, so that is also not correct. But the number that we can multiply by itself to get 36 is 6 by 6. So the square root of 36 is 6, and that is because 6 times 6, or 6 squared, equals 36. Now, what does this mean to be square? That means that we have 6 groups of 6. So here's 1, 2, 3, 4, 5, 6 groups of 6. And that's our 6 squared, or 6 times 6, 36. And if you make little marks like I did to represent perfect squares. They will always come out to be a square. Let me show you something. Let's try 2 times 2. Look at that. It always comes out to be a square. Let's try another one. Let's try 3 times 3. And look at that. It always comes out a perfect square. Let's try one more. Let's try 4 times 4. 1, 2, 3, 4. That's times 1. 4 times 2. 4 times 3. 4 times 4. And it too comes out to be a perfect square. So when you draw perfect squares using dots, as I have, they always come out to be square. And that's what we have for our 6 times 6. So that gives you kind of a visual idea of what a square root it is. So the square root of 25 says what times what equals 25. And we all know the answer to that is 5 times 5 equals 25. So also, positive numbers have 2 square roots. And let's explain why that is. Let's get some more paper. So, how can I get to 25? Okay, what are the ways that I can get there? Well, I can get there by 5 times 5. But remember, what's a negative times a negative? Well, a negative times a negative is a positive. So I can get to 25 with negative 5 times negative 5 as well. So I can say the square root of 25 equals negative 5 or 5. So both of those answers would be correct. What about the square root of 16? Well, I know 4 times 4 is 16, but what about negative 4 times negative 4? That also equals 16. So that's what we mean when we say that positive numbers have 2 square roots, because both the product of 2 negatives and the product of 2 positives is positive. Now, something else to know about square roots is that negative numbers have no real square roots. There is such a thing as imaginary roots, but you don't learn about those in this class. Now, these perfect squares that we sort of talked about when I went to my notepad and I drew these perfect squares. Okay, and then even this big one here. I drew those perfect squares. Well, it's a good thing to memorize those, and at least memorize the first 10. When you get to algebra, I say memorize the first 20. And here's what I'm talking about with the perfect squares. Let me get my highlighter back. So here are the perfect squares. And look at this. You see 1 squared is 1 times 1. So 1 is a perfect square. 2 squared is 2 times 2. So that means 4 is a perfect square. 3 squared is 3 times 3, which is 9. So 9 is a perfect square. 4 squared is 4 times 4. So 16 is a perfect square. 5 squared, we talked about that one. That's 5 times 5. So 25 is a perfect square. 6 squared is 6 times 6, so 36 is a perfect square. 7 squared is 7 times 7, so 49 is a perfect square. 8 squared is 8 times 8, so 64 is a perfect square. And let's write a couple more while we're thinking about it. 9 squared is 9 times, let's not use the little x, let's use the dot, is 9 times 9, so 81 is a perfect square. But what about 10 squared, which is 10 times 10, which is 100, which is also a perfect square. So these are the perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And if you were to look at a number chart, those would all lie diagonally right down across the number chart. Now, when you get to algebra and you solve equations, we'll learn how to solve equations with square roots. We're not doing that quite yet, so I don't want to spend a lot of time on that. But you do need to know about simplifying square roots. And that's what we're going to do today. We have 3 steps. Rewrite the radical as a product of the largest perfect square and another factor. Factor out the perfect square and simplify. So let's see how that looks. So if we have, let's get our colors ready, the square root of 24, I can rewrite that as, rewrite the radicand. This is called the radicand. We rewrite the radicand as the product, that means we're multiplying, of the largest perfect square and another number. So remember, here's our list of perfect squares. So what is the largest perfect square that can be multiplied by something to get to 24? Well, I know that 6 times 4 equals 24. And I know that 4 is a perfect square. So what I do is I take that 4, the largest perfect square that can be multiplied by something to get to 24, and I pull that out. But when I pull it out, it's no longer a 4, it becomes a 2. Okay, because remember, the square root asks, what times what equals 4? And the answer to that is 2 times 2 equals 4. So we're going to pull the 2 out, and then we're going to leave the 6 inside. And that is the answer. We've factored the square root of 24 as 2 times the square root of 6. Now, what about the square root of 90? Do we have any perfect squares that we can work with? I see that this 9 times 10 is 90, and 9 is a perfect square. But when 9 comes out, it becomes a 3. Remember, 3 times 3 equals 9. So when 9 comes out, we will have 3 times the square root of 10. Okay, so let's look at 300. So we need to factor the square root of 300. And we say, well, gosh, what is the largest number that's a perfect square that can be multiplied by something to get me to 300? Well, 300 can be thought of as 100 times 3. And we know that 100 is one of our perfect squares. So 100 comes out, but it doesn't come out as 100. It comes out, remember, 10 times 10 equals 100. So 100 comes out as a 10. The square root of 100 comes out, and the 3 stays inside. Let me erase a little bit of that. Made it a little longer than I needed to. There we go. And that's the factoring of the square root of 300. Now, to factor 2000, well, one thing I know, because I've memorized a lot of squares, and I've memorized them up to 20, and I happen to know that 20 times 20 equals 400. So I know that 400 is a perfect square. So 400 is a perfect square because it's 20 by 20. So I know that I can take, well, let's think, 20, let me just erase that. I didn't mean to say 20, I meant to say 400 times 5 equals 2,000. So the 400 can come out, but when it comes out, it will be a 20. So we'll have 20 times the square root of 5, and that is fully factored. So let's look at some of this error analysis, okay? So this person said that the square root of 36 is 18 because 18 plus 18 is 36. Well, that's not how square roots work. And that's the one we did as an example over here. This is this example right here. The square root of 36 is not 18, it is 6. So the problem is that they added, that's what they did wrong. To solve it correctly, the square root of 36 is 6 because 6 times 6 equals 36. Now here they're saying the square root of 800 is between 784 and 841. Well, how can that possibly be? Because if we multiplied these numbers together, we would have a much bigger number than this 800. We need to know what times what equals 800. Well, 800 is not a perfect square. So that's problem number one. 800 is not a perfect square. So let's think about what we can do. So let's see, we have 400 is a perfect square. So we need to find the square root of 800. So, and I know that 400 is a perfect square. So I think I'm going to think of it as 400 times 2. So 400 can come out as a 20 because 20 times 20 is 400. So if I have 20 times the square root of 2, that's my final answer. Now here, this is kind of an equation. They're saying x squared equals 576. So we know that that means something times something equals 576. Okay, there's no way that that is true. Okay, what did they do? Not with 288. What they did was they divided by 2. That's not the same as multiplying something by itself, so that's incorrect. So the thing they did wrong is they divided by 2. Okay, so if we want to find the square root of 576, we need to find a number that when multiplied by itself equals 576. What times what equals 576? Well, only because I happen to know the squares. I happen to know that 24 times 24 equals 576. And you can play with your calculator to get to the number. You can try 20 times 20, 21 times 21, and just keep going and kind of use trial and error at this stage of your math career to see what you can figure out. So if 24 times 24 is 576, then the square root of 576 equals 24, or to go back to the original problem, 24 squared equals 576. And in the last problem, it says x squared equals 16. Well, that's not true because 8 times 2 equals 16. So 8 squared is not 16. The square root of 8 squared means the square root of 8 times 8. Well, what is 8 times 8? 8 times 8 is 64. Well, what's the square root of 64? We actually have that right at the beginning of our lesson. The square root of 64 is 8 because 8 times 8 is 64. So the square root of 64 equals 8 because 8 times 8 equals 64. So let's go back to our exit ticket. What are the steps to simplifying a square root? Rewrite the radicand as a product, that means multiply, of a perfect square and another number. Okay. Second step, pull out the perfect square. Or the perfect square root. Leave anything that's not a perfect square in the radicand, in the radical. And the second question, why do positive numbers have two square roots? Because a positive times a positive equals a positive. And a negative times a negative. So there you go. Make sure you show me your work. If you show me your work, you get credit. If you don't show me your work, I have no idea what you're doing. So you have to show me your work. I know you can do it, and I know you can keep practicing hard. Square roots is something new. Don't expect to get it all on the first day, but keep practicing because as you do, you'll be great.